Welcome everybody. This is the first event for Innovation Week 2019, so thanks for coming. We have an action-packed week. If you haven't seen the schedule, you can talk to anybody that's on the Culture of Innovation team, and they'll tell you all of it. But there's Betty, what's the next event after this?
Tomorrow we have gaming competition in the morning.
There's a gaming competition for those of you
Then
who
we
like to
have
watch.
innovation panel at 1 o'clock.
And then an innovation panel, which will be interesting. We're going to have some customers. Some of our sales folks going to come in with an innovation panel, talk about innovation. And then when's the assembly challenge?
Assembly challenge is on Thursday.
Thursday's the assembly challenge, where you take a client team and you make them take a server apart and a server team, make them take a laptop apart and put them back together. So that's always fun. But hey, I want to get started with today's event, which I'm super excited about. Hey, when you guys were kids, who wanted to be an astronaut?
Me.
Huh? Doesn't everybody want to be an astronaut? And we've got somebody who's from that industry today who's going to talk to us. Dr. Chen is one of the principal scientists at a company called TiSpace. TiSpace. Oh, TiSpace. What did I say? I said it wrong. TiSpace. Taiwan Innovation Space. And it's actually, I don't know if you guys knew that, but there's a company in Taiwan that is basically in the business of sort of privatization of space technology, launch services, that sort of stuff. And it's really cool that we have a company in Taiwan that's doing cutting edge innovative products, solutions. Dr. Chen has a rich history in rocket and space technology. He's worked at lots of companies, including NASA, in this industry. He has a PhD in aerospace engineering, and he's also a really active member in a bunch of organizations, industry organizations associated with space technology. One of the areas he's focused in, and he was just telling me about this before a few minutes ago. But really, a lot of the innovation that they're doing is around creating more cost-effective and environment-friendly hybrid rocket systems, which is super cool. And so I will stop talking so that you can listen to him. But please help me welcome Dr. Chen.
Thank you for the nice introduction. It's great. I feel honored to be invited for the first talk about innovation, and I think this is also. We have one word, innovative, in our company name, so that's quite attached to the scene. So we started this company 3 years ago, and we think we can do something. And first of all, everybody knows space has been launched starting from Russia, United States, and all over the world, and go to the moon, everything. What's new about it? So, as you may notice, that recently the most famous person in space, Elon Musk, he just launched another 60 Starlink satellites. So that's going to usher in the new era of communication. And if we talk about communication nowadays, we use everything related to communication. And stuff from cell phone to everything, internet, and all the financial manipulations, financial controls, all related to networking. And now it's moving to space. And I'll talk about that a little bit, and what is the future for this. We are talking about multi-billion-dollar business and this. So Taiwan also need to pay attention to that. You cannot be left alone outside of this new realm of business circle. And let me introduce myself a little bit. I joined the National Space Organization of Taiwan since 2005, and before that, we were in Huntsville, Alabama. That was the first NASA center doing the rocket, building the rocket, and the most famous Saturn V rocket was built there, and sent the Armstrong to step on the moon, and so it came up with a very long, rich history in the rocket technology. And so when we look at this, everything actually start from here. Talking about space is it's born. Everything is born from the stardust. Everything we have, everything we own, is from there. And so all the scientific foundation, everything technology related, now we are doing business, is all based on these findings, start from the 17th and 18th centuries. So, and if we look at the system from the Earth going out to solar system and to the interstellar and the Milky Way, and the Milky Way become a small spot here. It's a local galactic group, and also the supercluster. And if you look at that supercluster, become this puff in the middle. And so far we know the observable universe is like this size. We have about 3,000. We call it the 300 sectillion. That's the word we never use, right? But remember, this number is from the observable, and the observable always got errors. So if you put it plus minus 50%, that's close enough, okay? And how big is the observable universe? Is 92 billion light years, and the light years is huge, right? So if you calculate that out, and that become this one unit called AU, astronomical unit. That is the distance between Earth to the Sun. And so this is how big the universe is. Wow. Now, so far we can observe, but people may ask, what is that beyond that boundary, right? So it's an observable boundary is there, so it's growing all the time. So there's still debate whether the universe is what kind of, how come you cannot calculate it? Even Einstein couldn't calculate it. So he used constant, so universe constant to make his equation balance. So we still have a lot of room to learn. So that means a lot of opportunity for research, for business, for everything. And this is a summary what we know as a human being so far. We know only about all these heavy elements. What we have all the material on the earth, in the sky, in everything. We only know about 5% of it. So there's also another 95% is unknown. And since it's unknown, so we call it dark. So it's dark matter, dark energy, that's still unfounded, right? So when we don't know something, we call it dark. So that's the way to do it. So we want to know all this. We want to find out where we are from. So we need to find out the answers. So before we do that, we need to leave the earth. We need to leave the ground and go to space and to find a new ground and find everything we don't know about. So that begins about 200 years ago. This is Sir George Kelly. He talked about in the future, people may use travel in the air. And if you look at his sentence, the last one, we can move things around, and then we can go to 100 miles per hour. Well, during that time, 200 years ago, they thought 100 miles per hour is really fast, right? And now we can do it in a few seconds, right? If you sit on a Tesla, zoom, then you can accelerate very quickly to that speed, right? And then about 100 years ago, Wright brother let us enjoy and find out how you can lift. But the most important thing here is not how he can fly. It's actually what it meant is how to control. If you can control everything, then anything can fly. Even a chair can fly, even a desk can fly, even this room, the whole room can fly if you can control it. So that's the new name of the game. When you go to space, you can come up with any shape you like, and as long as its energy is viable and you can control it, and then that thing is viable to live in the air and go to space. So the so-called innovation is you can wide open your thoughts. How can you come up with a new design to achieve the goal? So that's what Wright brother really told us. Not just simple, he's just very short flights, but that's the essence of his discovery. And this picture, I like it very much, is that if you understand the mechanics involved with this is when we fly a kite, you usually have a string attached to the kite, and the kite will be about 45 degree downrange and 45 degree up. That means your lift and drag is about the same if you use the simple concept. But this kite, his airplane, lift above their head. That means the drag is much, much less. It's about less than 10%. All the rest, the force is lift. So that's the one thing now we can travel in the air without using the same amount of force. For instance, if I lift up 1 kilogram of mass, you need 1 kilogram of force. That's a simple equation, right? But the airplane doesn't need that. The airplane only needs 10% of the force to lift the thing. So that's the most important discovery in 20th century. So aerodynamics, that's the science of aerodynamics. So this picture tells us that. And now we've mapped, fast forward this recent event. About 2 years ago, there's an X-47B, and then it takes off and lands on aircraft carrier of the San Diego in the Pacific Ocean. And there were 6 models of this flight, and they all takes off and land smoothly. And okay, it's too noisy. And the most important thing is autonomous flight. It's all fly by itself without human interference. And then lands by itself. And there's one flight did not land successfully, and the computer would reconfigure, and then he flew back to San Diego to land on the airport. So we talk about AI nowadays. It's already there. It's all in the so-called X program in DARPA. In DARPA in the United States, the DoD. And now, from airplane, the aerodynamics, and go into space. So you need to have a transition. So as I just mentioned from the Wright brothers finding, as you can control, then you can, and you need energy and control. These two essence, these two important material, then you can launch, go into space. And the difference, the main difference is when you are in the atmosphere, you have the air to control your vehicle. But when you go to space, there's no air to use. So you need to use the propulsion itself. You need to use the thrust itself to control everything. So that's the only difference. So let's talk about a few people so we know what's the how the technology built up over years. This is Frank Whittle. He's the British, and he was the first one to invent the jet engines. Now we can travel around the world all because of him. His effort later became the Rolls-Royce jet engine company. It's a major jet engine company in the world. And this guy, we call it Chuck Yeager. He's the one broke the sound barrier, and he broke the sound barrier because before that time, people thought when he approached the speed of sound, the airplane breaks up, and the reason nobody knows. So at that time, people thought there's a brick wall in the air. When the airplane tries to cross the sound barrier, then you break. And Chuck Yeager, his discovery actually along the same line as Wright brother, is control problem. When you go through the sound speed of sound and start to form the shock wave along the vehicle, and the shock wave structure changed. So you enter a realm called control reversal. So you thought you want to go down, actually it goes up. You want to head up, you head down. So that's the reverse. So Chuck Yeager discovered that when you want to control airplane going through the sound barrier, you control with the forward surface instead of tail surface. So you you find all the airliner, the horizontal surface behind it. There's also movable surface in front of the tail surface. And that's his contribution, major contribution. He almost died to find out the fact. And according to the movie, or according to his memoir, the morning he broke the sound barrier, he rode the horse with his girlfriend, right? And he fell, and he broke one of his ribs. But he thought he should pretend he's good. Otherwise, people will cancel his flight. So he have a stick bound to his rib, and then he complete the flight and find out how to break the sound barrier. So all things connect together is very interesting. And another guy is from Lockheed Martin. Is from the skunk work of Lockheed Martin. What he invented is the so-called systems engineering, the science of systems engineering. You know, Taiwan in the early time, we have the fighter called F-104, the Starfighter. And that Starfighter is the first supersonic interceptor in the world. And this team made it from concept to the test flight in 1 year. Can you believe that? That's how efficient that team is. And it's all because what he invented, so-called systems engineering, how you integrate all the complex system all together and then go very efficiently. And that tells us the team, how you build up a team to work efficiently. And the system engineering tells you that. Systems engineering is all about managing people. It's not about technology per se. It's about managing people. And then he can come up with a very efficient way to manage people and to meet the schedule, what he promised, what he wanted to deliver to DOD. He said 1 year, then he did it in 1 year. And there's another example, very impressive example, is the first 3 times speed of sound reconnaissance airplane, the so-called Blackbird SR-71. He did that, also the first one in the world. New material, new concept, new engine, everything new in 2 years. From concept to flight. So you see the power of management is so important. And this guy, I think everybody knows, is Elon Musk. People in the early days, people think he's crazy. He want people to migrate to Mars, right? and one-way trip, one-way ticket. Anybody want to go from this room? Well, he also, the most amazing part is he said a rocket, he want to reuse the rocket. So the rocket want to, after the launch, he want to fly back to land on the launch pad. And then people think he's crazy, right? A rocket basically is just like a missile. And if you see the video and see his record, flight record of the booster he brought back to land, the average speed from the departure come back to the ground is a supersonic. So the average speed is supersonic, and how can you sign off to approve such a test from a range safety consideration? A missile coming back toward you, and with a supersonic speed, how can you approve that? And I think all over the world, only United States can do that. That's true. That's true, because they are daring. They are always daring and go for unknowns, and even if few sacrifice, that's okay. Right? So be prepared. And this guy, Dave Thompson, I know him because he was working in the UTSI, Tullahoma, near Huntsville, Alabama, and the famous thing he did was so-called air launch. It was so-called. There's a rocket called Pegasus. Pegasus rocket sitting on the belly of a Boeing 727, and then dropped and then launched to space. And that's his concept, and he did it. The most amazing thing is that he did not do any tests. He did everything on computer. Use computer simulation, and at that time we told him you must at least do one wind tunnel test. He said, I'm very confident. And then he did it one shot, and it was successful. So you know that nowadays computer is so powerful. You can simulate everything, all the detail. So if you use a very high resolution simulation to do it, then you can make it. You can do it very close to reality, especially for flying aerodynamics. And another guy is this Bird Lieutenant, and Bird Lieutenant is this guy, and this Richard Branson. He's Virgin Air. Yep. He's the chairman of Virgin Air, yep. And he invests in Bird Lieutenant to come up with the Virgin Galactic. What they do is so-called space tourism, and this guy is the first person to bring the so-called composite material, the carbon composite, really apply to aviation. He did a lot of record flying, like propeller aircraft, non-stop around the globe. That first time, 2 person in that Voyager. It's called Voyager. And the second time with a jet engine, also around the world. So he used the composite material to make the airplane so streamlined, so smooth, and so highly efficient. And that's how he can achieve all these feats. It's really not easy to do. And that's why nowadays all the major airlines start to use more and more composite materials. He made the pioneer work for this industry to adapt the composite material into the products. And now the space tourism, each ticket is about $250,000, right? And it's now on New York Stock Exchange, the company, but still haven't sent a passenger yet. So they still need to prove the space tourism is viable. But I think it should work in the coming years. The reason for that is it is everybody, just like first we ask who want to be an astronaut, right? And then this one, what he provide the service is that you experience how to be an astronaut. The $250,000 include all the training, the physical training, and then all the technical training, similar to the astronauts. So it's not too bad for $250,000. And I know in Taiwan we have a couple of tickets who purchased it. There's one person I know in Taichung. He's the owner of a steakhouse. Steakhouse, yeah. And he purchased one ticket. He's waiting for that flight. So the original, the first 600 tickets are all sold out. That's why he, based on that income, then he go to the New York Stock Exchange. And another side of the story is for rockets. And this is a Polish Russian guy. He's the so-called father of rockets. Because he first derived this so-called rocket equation, the velocity related to amount of propellant burned. And another three guys, his follower, this guy is a Russian. He's a Russian father of rockets of Russia. And this is the father of rocket of United States, Goddard, as the first person to come up with a liquid rocket engine. That's his design. That's very early on. But all these people, they do not communicate because during that early time, there's no internet, nothing, no easy communication. So all these three read the publication of Tchaikovsky and became very interested in rocket science. And this guy, he's a German. During the Nazi German era, he was the mastermind for come up with a V2 rocket to bomb London. But his contribution is after 60,000 tests. That's according to the history book. At least 60,000 tests. And he finally come up with one system that is good for rocket launch. And so the concept and the system architecture we used nowadays all follow his concept. So that's his contribution. So if you today, if you go to Huntsville, Alabama, along the highway, you can see the V2 rocket model. And if you visit Moscow to look at the museum, you can also see the V2 rocket, because both countries start from V2. They reproduce the V2 and then redesign their own rockets. And this is the original about 300 scientists who were surrendered to the U.S. Army before the end of the war. And it's according to the history book, they say it's a democracy. When they decided, they vote which country they want to surrender to. So they calculate which one is better. And then England is in ruin, and Russia is a dictator, and Europe is not good. The best one is USA. So they surrender to a private. All 300 also scientists surrendered to a private. And the United States was very happy. All these scientists, so they first, before the end of the war, they brought them to Lubbock, Texas. But there is too much wind, too windy, and too much sand, not good for rocket development. So they moved them to Huntsville, Alabama. So the last Russian scientist I know is my friend, Mr. Dom. He died about 5 years ago. The way he died is the last day when he drove to work, then they hit a tree because he had a heart attack. He worked until the last day. He's a very diligent and a very smart person. When I have something I don't know about the literature, I will go to him to ask, and he will tell me, go to the library, second floor, which bin, and look at which book. That's how he worked. So that's the person, Mr. Dang. That's the last German working in NASA Marshall. And during that time, United States gave them a very good treat. All these scientists have a so-called super grade. Super grade is in all the civil servant, you cannot have a salary higher than senator or congressman, and they did. They had this super grade because the President Kennedy gave them the special treat during that time. So von Braun came up with this, with also U.S. contractors, Rocketdyne especially, come up with this Saturn V rocket, and that so far is still the most efficient rocket in the world. It can send the most percentage of mass to orbit. Even now, no rocket can compete with this one. It's a very efficient system, but the 1957, Russia got the first shot going to use this Korolev's rocket, and they are still using this similar rocket today. But United States catch up right away and then won the moon race. And this is the now the SpaceX is doing the landing, auto landing stuff, and this actually is not a new technology. It's old. I also was part of this research by so-called DCXA, and it's a vertical takeoff and landing vehicle, space vehicle. And during that time, all the technology needed to vertically launch and land a rocket is already done. So after SpaceX announced they want to reuse their booster, then all the engineers joined SpaceX. So that's why SpaceX can progress so fast after they announced they want to recover their booster. As you can see, all this, at that time I was doing the so-called base heating because you have 4 engines at the base, and the bottom is going to be very hot. So you need to know how much material needed to protect the vehicle. And too much, too heavy, too little will be dangerous. So it's a very fine balanced act in order to come up with a good system. So you can see you can land very crisp. And so that's 1995 and 1996 technology. And then this is a few years ago. So 2 years ago. Quite incredible. And the one launched last night is the 4th. They used 4 times already, the booster. They recover and you reuse 4 times. And this is in Texas, Boca Chica. He's building Starship. And this is in Cocoa, Florida. He's building the booster of the Starship. So he's very busy now. He's very busy trying to go to Mars and go to the moon first and go to Mars. And this is his concept of how to enter the Mars atmosphere. We'll wait and see. Now nobody say he's crazy. So, and this is the opportunity we're talking about, the space communication. He launched now 120 Starlink satellites, and this will be near future in a couple of years. And this probably in 6 years, he's announced this 42,000 satellites. You can see the sky is going to be crowded after that. But the opportunity is here. There's a great opportunity for cost-effective small rockets. As you can see, satellite has power, needs power, and his battery inside. And battery has life. All the low Earth orbit satellites recharge 15 times every day, because they go around the Earth about 15 times a day. So it discharge, recharge, discharge. So the battery is going to wear out very soon, right? 5 years, 7 years. So after that, now he can launch 60 satellites at one shot, but afterwards, each satellite is going to retire one by one. So how is he going to use a big rocket to serve? Oh, this is small satellites. Each satellite, this Starlink satellite, about 225 kilogram, and you don't need such a big rocket capable of carrying 10 tons of payload to replace the satellites. So we see there's opportunity down the road, and it's going to be a perpetual service in order to maintain this network. You need small and very cost-effective rocket to provide the service, maintenance of his network. So that's recap from Goddard, and then come down space race, and then most important one is start from year 2000, then the space privatization, space launch is going to be done by the private companies. And then after that, Jeff Bezos jumped in. That's the first private company, Blue Origin, and 2 years later, SpaceX. But up to the present time, Jeff Bezos still have not launched satellite yet. So he's still he's doing his catching up. And another 2 years, Virgin Galactic, and another 2 years, Rocket Lab. And 10 years later, we have TiSpace. So, and we came in late, but we are about to launch. About end of this year, we are going to launch. So we took about 3 years, a little bit over 3 years to have a first launch. And the most efficient, Elon Musk, took 5 years to have first launch. So there's a progress. We learn more things from history. So currently there are new trends that the small rocket is needed, as I mentioned. So there are more and more companies come up, even China. Also, they said probably over 20 private companies. And we know it's all those companies are backed by the government. It's not like in the West, everything is really private companies. So this is the driver. From 1G communication, and about every 10 years, you go to 1G to 5G, and that's the current status. And now doing the lots of widened construction of the 5G on the ground. But the competition is going to be so-called 6G. And 6G is the bandwidth is going to be very, very wide. And we are talking about 100 gigahertz, 100 gigabits per second, the communication rate. So that's a very high rate of communication. And now, according to the current tests, the only thing we want to solve is the latency. Now the latency is still a little bit long. So they want to shorten the latency to less than 20 milliseconds. And that will be a very, very good for the IoT applications. So the main player will be, since it's a communication satellites and a huge number of satellites, so rocket is the only way to maintain the network. And after this, then there will be worldwide use of the internet and also the IoT. And as up to this present moment, we have about 50% of population who cannot access to internet. So this is going to open up the opportunity to the other 50% of the world population. And that is going to create more business and more applications, and then shorten all the communication roadblocks for everybody in the world. So USA, SpaceX, Blue Origin, OneWeb, as you can add up all these numbers, and plus the 30,000 new registered by SpaceX. So there will be about 50,000 satellites to be launched and to be maintained in the future. Of course, China is also, they started to catch up the 6G technology by doing some investment in Canada about 2 years ago. And all this, the difference is SpaceX, Blue Origin, these two companies use large rockets. And Rocket Lab is the only one, the only small rocket company in the world now. It was founded in New Zealand, but now it's an American company because Lockheed Martin invests the main portion of their share. So now it's based in LA also. So let's compare. All these three companies, they use the liquid rocket engine, and we use hybrid rocket. That's the main difference between us and them. And Rocket Lab has some innovation. He used 3D printing, and he also used the electric motor to drive the turbo pump. As we know, the liquid rocket engine, the most difficult part is the turbo pump. And that is the most expensive and most time-consuming parts to make. And Rocket Lab solved the part of the problem by using current electronics and 3D printing of the engine. But it's still high. So recently he just announced he will also want to recover his booster. I met him in Washington, D.C. 2 weeks ago. There's a big show, so-called International Aeronautics Congress in Washington, D.C. Commemorate or celebrate the 50 years of moon landing. So that was a big conference. And Peter Beck was there also. So I talked to him about his schedule. So he's going to test his booster recovery in about 2 weeks. So we'll wait and see. Now talk about us. We have a hybrid rocket. And the hybrid rocket, the basic character is safety. It's very safe. No possibility of explosion. So that's how safe it is. And because of that, it's designed very simplified, very simple. The system is very simple. So the cost of production is very, very low. And it's very good for Taiwan's industry to mass produce them. So the mass production is going to be very easy to streamline. So let's talk about us. The TiSpace, we headquartered in Taiwan. Now we register in California, in LA. So we are going to launch rockets not only in Taiwan, also in the US and also in Europe. We are talking to Norway, to Sweden, and to Australia. And this time in Washington, D.C., we found that all the launch sites, all this country around the world, especially you have shorelines countries, they are all promoting their launch sites. Now they want to make launch sites available to all the rockets. So even Australia is building a new launch site, and also even Hawaii also came to promote their launch site. And England, Scotland, around Scotland, there are 6 potential launch sites now in construction. So you know everybody's ready to get into this business, and the launch is one important part. So we are going to go to United States and then go to Europe and Australia and all over the world. So that's our plan for the near-term business operation. Our headquarters in Miaoli, Zhunan Miaoli, half test site in the mountain. We purchased one mountain area to do the test site, and launch site in the southeast corner of Taiwan. So we start the business. The business was founded in 2016. Now we have about 104 people, mostly technical persons. So the average age is 34.5. So it's still young, but I'm the person who make the average up. And this one explain why it is so safe. There's a here so-called TNT. TNT, you know, is the explosive. And the TNT, this is number assigned to hybrid rocket 0 is not assigned by me. It's assigned by U.S. Air Force and the NASA. They assigned this number because during the years of developments and testing and flight, never had one instance of explosion. No matter how you do it, you try to let it explode, never explode. The reason why is hidden in this physics. We have the hybrid rocket. The so-called hybrid rocket is a part liquid and part solid. And the liquid engine is both oxidizer and fuel are all liquids. And they store in separate tanks. And the hybrid rocket is a part liquid and part solid. And when it needs combustion or needs burning, it needs certain condition. Without that condition, you cannot burn the solid fuel. And the solid rocket is the oxidizer, solid oxidizer, and solid fuel pre-mixed and make it into a grain shape and then start burning. So the most dangerous is this solid rocket. And the next is these liquid rockets. 2 years ago, the SpaceX was fueling on the launch pad and preparing to launch the satellite of Facebook, and that cost $200 million, the satellites. It exploded when it's fueling the liquid oxygen, and all of a sudden, boom, it's gone. So Facebook they had to make another satellite, spend another $200 million to come up with a satellite. So that's the nature of the game. The liquid rocket and solid rocket, they explode. So all the procedure must follow very strictly in order to make sure of safety. So as you can see, then it's going to drive the cost up. Not only in production, also in operation phase. And the hybrid rocket, you don't need that. There's no way hybrid rocket will explode. And another side of the coin is this one. On the horizontal axis, this is called engine efficiency. And the vertical is a propellant density related. And there's a dotted red circle. And I use two vehicles. One is the space shuttle system. And the space shuttle system has a solid and also has a liquid. And if you average their energy, and it's somewhere also in this circle. And SpaceX Falcon 9 rocket also in this circle. And we are also in this circle. So our system, according to the physics, also is viable to launch satellite into space without any problem. So what we have is we have hybrid rocket, advanced hybrid rocket. And people may ask why other, like NASA and other people, other company did not use hybrid rockets? Because before this time, the hybrid rocket efficiency is not high. They have been struggling all along the way. But we have an invention, we have an innovation, proprietary technology, make it efficient all the way. So we now achieve the so-called Class 1 propulsion system. It's done here in Taiwan. Thank you. So, and with that, we are going to have this. We use the cost effectiveness, and then we have a mass production capability, and we can go out to the world to compete with others. So you must prepare for your emulation in order to face all the big guys, and we are not going to be in competition with all those big guys. We are going to be in collaboration with them because they are going to place all those satellites in space, but we are going to maintain them. So we need to become partner. So now our company is going into this next phase is looking for an international partnership. So we travel to Los Angeles, travel to the United States, and talking to them, and we are going to initiate all this collaboration phase to let us step into this arena of a space race, another space race. So this is our rocket. The architecture is going to send mainly we call it a dedicated service. We send a major satellite, and we have extra room. Then we can carry some small so-called CubeSats to do the testing. And so far we have two vehicles. One is the so-called suborbital launch vehicle, and this big one is an orbital launch vehicle. And the suborbital launch vehicle mainly for technology development. So it's not flying too far, so you can test technology very quickly. And the launch vehicle itself, we can launch up to 700 kilometers and carry the satellite up to 390 kilograms. And all this number is because we are looking at in the future the majority of the communication satellites all within this range. It's all below 300 kilograms, and the altitude, the orbit altitude around all below 700 kilometers. So we design specifically for that application, for communication satellite applications. So we want to go into the the largest piece of pie of the commercial realm. So this is a 3-stage rocket. We launch. We send the satellite to the. This is the upper stage, and in the process there was stage separation and fairing opening, and then satellite injection into orbit. And after that, we do the deorbit for the upper stage. So the upper stage is going to slow down and then re-enter the atmosphere and to burns up completely. So we don't need to leave any space debris in space. And this is another advantage of launching from Taiwan. From the southeast corner, you launch the so-called low Earth orbit satellites, and you can go to different angles. And this is similar to the Cape Canaveral, Florida. But the Taiwan has a lower latitude. The latitude is about 22 degrees. So it's lower, and the lower latitude gives you more energy doing the satellite launch. So from Taiwan, if you launch satellite, you can have an angle, this angle up to 60 degrees. And when you go up to 60 degrees, that means the satellite can cover the ground area from plus minus 60 degree in latitude. That means you cover the entire world population. So if you launch the communication satellite from Taiwan, you can serve. You can replace any satellites, the LEO satellites in space. And this is a tank we use, and it's not easy to come up with a big tank because the machine that makes the tank is a control item. It's an export control item. So we have no other choice but to make it ourselves. So we make the machine ourselves in Taiwan. So Taiwan, there are lots of talents. If we start doing the design, and we know the spec, and then we just determined to do it, then we can make it. Anything we can make it. This, after we make it, and we compare to the price. If we buy it from a foreign country, we are about 80% of their sale price. The development cost is 80% of their sale price. So what tells us that if we make everything in Taiwan, it's a lot of advantage. And also in Taiwan, the Formosa Petroleum Company, they produce the carbon fiber. There are not many countries in the world can make carbon fibers, but Taiwan can do it.
So are you also selling to other companies?
Yes. Now there's another application. Now is new energy, green energy application. Nowadays we also talk to some automobile companies to use hydrogen as a fuel in the future. It's a true green energy application. And to use hydrogen, you need to high pressure tank. So this is a high pressure tank. So our byproduct is going to make many carbon fiber tanks for the hydrogen energy applications. And okay, this is for this NSPO, National Space Organization project. So our next 5 years plan is this. We want to launch now, and orbital tests in the start from Q1 next year, and then start from the Q3 of next year. We are going to provide service, satellite launch service. May not launch from Taiwan, but may launch from other places. So we are now engaging in those launch sites to make them available when we have customers. So we are now signing up customers. And the most important one is that in 2023, we are going to make 2 launches per week. So that's our aim. You know, so far in history, there's only once that over the world, the number of launches above 100 times. That's the last year, 106. And then this year is going to drop below 100. So 100 is one paradigm, and we want to break it. We want to break the paradigm of a number of launches. So we want to over 100 in a couple of years. So that's how we do being business-wise. And as I mentioned, so this will be the world, future of the world. Everybody communicates through satellites, and you can go anywhere in the ocean, up in the mountain, everything. So that's our innovation. Thank you very much.
That was awesome.
Thank you.
Very nice. Thank you so much. We have a gift for you.
Oh,
Because
wow, how nice.
What you need is another coffee cup at home.
Yes.
And,
Yes.
So
Yes,
thank
I
you
drink
so much.
coffee.
Yeah, good.
Yes.
Yeah. But yeah, thank you. We probably have time for. We're a little bit out of time, but anybody have a quick question?
Yeah. So if I wanted to go and see one of your rockets launching, could I just come to Taiwan and show up, or?
Yeah.
To buy a ticket.
Yeah. There'll be a control area.
Yeah.
So it will be outside of the control area. That's fine. Yeah.
Okay.
No drones.
Yeah. Since it's a non-explosive rockets, so the area is short. Is
get nice
smaller.
close.
Yeah. Smaller. Yeah.
Your supply chain mainly is in Taiwan or China, so you see the benefits building a company here. From
Supply.
chain perspective.
Oh, Taiwan's supply chain is superb. 100% from Taiwan. We only buy. There's one couple of things like gyro, the fiber optics gyro. We have 3 sources: United States, Italy, and Russia. So only this item we purchase from outside, and all the rest, 100% MIT.
MIT. Awesome. Anybody else?
So who will be the potential client for TiSpace?
For TiSpace, we now signing up. Yesterday, we have already signed a memorandum with National Central University. That's our first memorandum. They are going to have several satellites launched in the coming years. So we have signed it with the principal, the chancellor of the university, and we also talked to National Cheng Kung University, and talked to people in Poland, Spain, and also in Britain, also. So we are signing up customers right now.
Does anybody want to sign up?
Yeah, you can 3D print a satellite, and we can launch for you.
I'll launch it. question over here.
You just mentioned that the ability to launch is the key, and also the fuel could be the the critical as well. So do we make the solid fuel here in Taiwan, or we just source it from U.S.?
Okay, let me tell you, our solid fuel is running on the street every day. The tire of Mercedes. Related to tire, the tire, rubber.
Oh, okay.
The fuel is rubber related, but synthetic rubber, so it burns clean. And then our oxidizer is most abundant in Taiwan and most high quality in Taiwan.
Taiwan beer?
Yes. It's a so-called laughing gas, the N2O, nitrous oxide. You know, nitrous oxide is used in all the fab, right? They use etching all the plasma and also that kind of thing. They use lots of nitrous oxide. So we can just pick up the phone and say how much we need, and they will bring it to us so easily.
No licensing from the U.S.?
No.
We can do it here locally?
Yes, 100%.
Great.
Yes.
Okay, one more. Anybody?
So, will you plan to be a 6G provider or focusing on the rocket vehicle?
Yeah, we are going to focus on rocket. But next year we are building a so-called space science park. We are going to invite more people, more investors to come up with a space science park, also not too far from our company. And also we want to build rockets, the production line, and also satellites. So we want to integrate so-called complete vertical integration of the space industry.
All right, one more round of applause for Dr. Chen. That was awesome.
Thank you.
Fantastic.
Thank you.
Thank you. Awesome. Really good.